started. So let's work on that more, and then we'll go forward from there. Okay, let me share a document so I can actually write. Did we talk about the parent in an alkene? Did we talk about what is a parent in an alkene?
Mm-hmm.
Yeah? Okay, there we go. I got it now. Okay.
Yeah, we went over the example of hex 3-ene, and I think that was it.
Okay.
Yeah.
Cool. Okay. Thank you. There we go. Now I'm sharing. So I think what I said was that the word alkene can be divided into 3 parts, right? And that's kind of the concept with IUPAC naming. This is why IUPAC naming actually is so versatile and convenient to use, is because every part of the word tells us something. So depending on the big molecule, you can change whichever part needs to be changed and leave everything the same. So as you will see, as we name more and more different families of compounds, you will see how that makes the process be very versatile, and you can apply it pretty much to any family of compounds. So once again, just a quick reminder, the term alk, the portion alk, gives us the number of carbons in the parent, and the parent for an alkene, must contain the double bond. So it is the longest carbon chain that contains the double bond. And if there were more than one double bond, then it must contain as many double bonds as possible. And we'll look at those examples as we go. The ene is telling us that the parent has carbon-carbon double bond. And the E at the end is telling us there are no heteroatoms, the compound is a hydrocarbon, right? So the first step, as always, when you're doing IUPAC naming, is for us to figure out the parent chain. So let me draw something, we'll go through some examples, okay? So give me a second. Okay, let's see. The first step is for us to figure out the parent. And the parent has to be the longest chain of carbons that contains the double bond. That's the important part. It must contain the double bond. So what will be the parent in this example? Anybody? Will it be 1, 2, 3, 4, 5, 6? Or will it be 1, 2, 3, 4, 5? Or 1, 2, 3, 4? I'm seeing different options. What do you guys think?
Longest carbon chain.
No, so which one is that in this case? But it must
Is that a hexene?
It must also contain the double bond.
Hexene.
Meaning the double bond should be part of that chain. If you do hexane, is the double bond part? If I choose this as my parent, yes, it is hexane, I agree, but is the double bond included in that?
No.
No.
Would it be butene?
Okay, so one option is 4 carbons. So do you mean this butene? It contains the double bond. Yes, absolutely. That's one option. Is there another option which may be longer?
Oh, starting from the right?
So that's pent, 5 carbon.
Yeah.
Hello.
Hello.
Oh, okay. I
Hi,
couldn't get my microphone to work. There we go.
Oh, perfect. I thought you were just saying hello to me in that weird way. What's wrong with that?
Hi.
It's not Halloween yet.
I was saying it for like the past minute.
I'm just kidding. Do you guys agree there are 2 options here of chains? Oh, there's one. Oh, right. You said right. Okay, I'm so sorry. 3 options. Okay, so contains the double bond, but going here. Should I record this or is everybody here? I don't know if oh yes, everyone is here. Everyone's here. Okay, good. So there are three options of chains that will contain the double bond, right? But which of these is the longest?
The pentene chain.
Exactly. So the parent for an alkene is the longest continuous chain that contains the double bond. Everybody okay with that? And now we number the carbons in the parent so that the double bond gets the smallest number. The double bond gets the priority, guys. So we need to number the carbons in the parent chain to give the double bond the smaller combination of numbers. That's your first priority. So which side should I number the parent from?
Starting from the double bond, 1,
Right.
2, 3, 4, 5.
That takes priority. And now we name. So do you guys want to give me the name of this compound?
Yeah.
Go ahead.
Is it 2-ethyl 3,3-dimethyl pent 1-ene?
2-ethyl 3,3-dimethyl. And what did you say after that?
Pent-1-ene.
Good. That 1 is giving us the position of the ene. Everybody okay with that? Why am I writing slanted? Oh, I need to. Okay. But do you all agree with that? Does that make sense, everyone?
Yep.
Okay, let's try a few more. Let me draw first, then we'll work on the naming part itself. Okay, let's try this. And while you're thinking about it, I'll try to draw more. Okay. Let's start with the one on the left, the first structure. So first step is find the parent. Can you tell me how many carbons in the parent for the first?
7.
Heptene.
7, I heard. 1, 2. So do you agree? 1, 2, 3, 4, 5, 6, 7. Do you agree?
Yes.
Yep.
C.
Have I numbered it correctly?
I
The
think
double
so.
bond should get the smaller positions, right? Okay, let's name it then. Go ahead. What would you call it?
4-ethyl 2,5-dimethyl hep-2-ene.
Did you say 2? Yeah, 2,5-dimethyl
Yeah.
hept 2-ene. Everybody agrees with that? Okay, next one. What's the parent?
Octane or octene.
So 1, 2, 3. So I'm numbering from the end closer to the double bond because that way the double bond gets the smaller position, right? Do you all, oops, that's 4, 5 comes after 4. 5, 6, 7, 8. Everybody agrees? And then we name, okay? Who wants to go? Would it be
E, F, G, H,
7 bromo,
K.
right?
Would it be 7 bromo, 4 butyl,
Very
2
good.
chlorine,
Chlorine.
or is it?
No,
Oh,
you're right, but what would you
Oh.
call it? Will you call it
oh,
chlorine?
chloro,
Chloro.
oct 3-ene.
Chloro, oct, 3. Perfect. Yep. Everybody agrees? Okay, what about the last one that's on the screen?
It's,
I can
is it
try.
2 chloro.
Oh, Mark, let
Yeah.
Mark go this time. Yes, Mark, go ahead.
I'll
Try.
probably be wrong, but I'll try.
That's okay. Again,
Two-
we are trying. Yeah, go ahead.
2 chloro,
So, okay, go ahead. Yeah, 2 chloro, go ahead.
7 methyl,
7 methyl,
oct, and I think it's 4-ene.
1, 2, 3, 4, 4E. Could we not have counted from the other side? Meaning, what if we had counted from the left and gone right? Wouldn't the alkene still be 4-ene?
Yeah.
Yeah.
It would be the same.
So
Yeah.
why is this better than the other?
I thought for some reason like we would stick the lower number with the lower letter.
Okay. I think what you're saying is absolutely right, just different words.
Like the chlorine, it comes first alphabetically.
So the point is, this gets priority first. We want this to be the smaller number first. And then if you come to a situation where that is going to be the same no matter which direction you count in, then the positions of the groups. This is the second priority. Does that make sense what I'm trying to say here? Right? So the first priority is to give the double bond. So you're absolutely right, Mar, your answer is absolutely right. So the first priority is to give double bond the smaller position. If that is going to be the same in either direction you count, then you want the groups to get the smaller combination of numbers. Everybody okay with that? Let me draw one more structure to illustrate another point here. Give me a second to draw it though.
Can I ask a quick question?
Mm-hmm.
If I reverse that, you'd still have 2, 7, but then it's alphabetical, right?
Exactly. That
Okay.
exactly. Then it's then the third priority. Okay. Second priority is to give the groups this. Okay. Let me write this down instead of just saying it. Let me just write it down. So the first priority is for us to number the carbons so that these get the smaller position. If that is going to be the same in either direction, then the second goal for us is to make sure the groups, substituents, the branches have a smaller combination of numbers. And if that is going to also be the same, such as in the previous example that we did, if that is also going to be the same in either direction that you number your parent chain, then yes, alphabetically smaller group gets the smaller number. So you do have to go in this order though. So first look for that carbon-carbon double bond, then look for the smallest combination of numbers for the groups, and if that is also going to be the same no matter which direction you count in, then the alphabetically smaller group gets the smaller number. Everybody okay? What if the double bond is in a ring? If cycloalkanes are possible, can cycloalkenes exist? And the question is, why not? That's a cycloalkene. The steps are exactly the same as before. Those don't change. Meaning, choose a parent. What's the parent in this case?
The ring.
The ring. Number the carbons in the parent to include the double bond, so the double bond gets the smaller position number. So we have two options here. We can either go start with the double bond 1, 2, 3, 4, 5, or we could start with the double bond on the other direction. Start here 1, 2, 3, 4, 5. Which is a better option, the orange or the green?
I think
The
the
green.
green would be better because the
Good.
branches are on the smaller number.
Good. So we all agree that orange is not a good option. Can I do this, guys? Can I start here? 2, 3, 4, 5.
I'm guessing not,
Why not?
because we have to start on the alkane.
What do you mean you have to start on the alkene?
On the double bond, we have to start.
Double bond, alkene.
Yeah,
Alkene.
I'm
So,
sorry, that's my pronunciation.
You're absolutely right, Mar. The rule is that the counting should include the double bond. The double bond should be part of that counting process. It shouldn't be on the outside of that counting. Does that kind of sort of make sense? So you're absolutely right. That is not allowed either. The double bond is included in the parent chain. It's on the inside of the parent chain, so to speak. Okay, can someone tell me, take a guess what the name will be here? So start with the groups. What are the groups?
2-methyl.
3,3 dimethyl.
3,3-dimethyl